Welcome back to the FlowArt Institute Fire Safety Video Series. This video deals with the science behind fire. As fire performers and fire safety personnel, it is vital that we have a basic understanding of the science behind the element that we work with, fire. So what really is fire? Fire is scientifically defined as the rapid oxidation of material in the exothermic chemical process of combustion, releasing heat and light, among other reaction products. But in common terms, this means that fire is a chemical reaction involving oxygen, which gives off heat and light and other byproducts of the reaction, including things like soot and smoke. Actually, heat and oxygen are essential components of fire and make up two of the three sides of the fire triangle. The last side, of course, is a combustible fuel. The fire triangle is a simplistic but accurate representation of the components that need to be present to start a fire. Once a fire is lit, a better graphical representation of an ongoing fire is the fire tetrahedron, which includes the three components of the fire triangle, but also indicates that the chemical chain reaction between the three components of the fire triangle is essential to the continuation of the chemical reaction that we know as fire. It's important to know the difference between fire and flame. Flame is the visible manifestation of fire, with the color of the flame being determined by multiple factors, including the fuel that's used, the amount of oxygen fed to the fire, and the heat of the fire. For instance, a yellow flame color indicates incomplete combustion, where oxygen and heat are not present in the right ratio to use up all the fuel, while a blue flame indicates complete combustion, where oxygen, heat, and fuel are all in the correct ratio for the full chemical reaction to take place. Flame color also gives us an idea of the temperature of the flame that we're dealing with. For instance, during a fire performance, the hotter white, orange, and yellow flames are produced from the beginning to the mid portion of most burns, with cooler red flames produced as the fuel is exhausted. Colored flames can also be made by burning different fuel combinations. For instance, a common, albeit unhealthy combination includes the use of a denatured alcohol fuel mixed with boric acid, which produces a green flame. So let's review. Fire is a chemical reaction which requires three components: heat, oxygen, and fuel to ignite. And once a fire is ignited, chain reactions between the three components continue the chemical reaction we know as fire. Finally, flame colors can indicate the completeness of the combustion process as well as the temperature of the flame. Before we finish, I want to remind you that no matter how much we understand about fire, it's still quite a dangerous and destructive process. For instance, at mid-burn, a fire performer's wicks come close to a temperature of 1,000 degrees Fahrenheit, certainly enough to cause a severe burn on exposed flesh. For more information on how to keep safe, please tune in to our next video. And thanks again for watching the FlowArt Institute Fire Safety Video Series. I'm Howard Chen.